Hi students, so we're going to start with Pythagorean Theorem number 1, our new unit. The first set of instructions, find the area for each square, write the solution inside each square. The first one is done for you. Make sure to show your work. So if we have a square with a side length of 3, then the width would be 3 also, and 3 times 3 equals 9. So the area of this square is 9. You're going to be asked to find the areas of all the other squares. So let's try another one out. If I have a square with a side length of 7, my width would also be 7, and 7 times 7 equals to 49. So the area of this square would be 49. So that's for problem number 1. You need to find the area of each squares. For number 2, it says, the Pythagorean theorem states the sum of the areas of the two squares on the legs equals to the area of the square on the hypotenuse. You're probably wondering, what does legs and hypotenuse mean in math? We'll discuss more about that in our next assignment, but for now, I want you to find the sum of the two smaller squares to equal a larger square. You want to use the squares from problem number 1 to help you figure that out and what goes in the blank. So let's say, for example, I have a square that is 12 squared. So I'm going to draw my triangle first. And like I said, we'll describe more about that in a bit, about what Pythagorean theorem means. But let's say one of the squares is 16, with a side length of 16, and another square has a side length of 12. If we want to find the area of the orange square, we do 12 times 12. 12 times 12 is the same thing as 12 squared, and 12 squared is 144. Now, let's say we want to find the area of the square with a side length of 16. Its width would also be 16, and to find the area, you do 16 times 16, which is equivalent to 16 squared, and 16 squared is equal to 256. So we take these two squares, 12 squared and 16 squared. So 12 squared plus 16 squared. And the question is, what do we get when we take 12 squared plus 16 squared? Well, 12 squared is 144, and 16 squared is 256. When we add the two, we end up getting 400. When you add these two squares, the smaller squares, you end up getting the larger square. And our larger square will be 20 as having its length and width. So 20 times 20 is equal to 400, which is the same thing as 20 squared. So on the left-hand side, we have 12 squared plus 16 squared equals to 20 squared. 12, a square with a side length of 12, a square with a side length of 16, and a square with a side length of 20. So 12 squared plus 16 squared equals 20 squared. 20 squared equals 400. Therefore, 400 equals 400. We know that works. Let's experiment by picking 3 squares at random. Let's say I pick 3 square and 4 square. Does that equal 15 square? So we're going to plug it into the equation. So we have 3 squared plus 4 squared. Does it equal 15 squared is the question. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. 15 squared is 225. Does 25 equal 225? No, not in this case. So that means we know this last answer of 15 square cannot be it. It doesn't work. 3 squared plus 4 squared does not equal to 225. So we can't use the number 15 as our last square. We'll have to pick another one of these squares to figure out what 3 squared plus 4 squared equals. Remember, 3 squared plus 4 squared is 25. Think about it. Which one of these squares would fit to be the last square of the sum of the two smaller squares? As a reminder, you only use each of these squares once. There are 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 blanks, and there are also 9 squares. So you should not reuse any of the squares more than once. For problem number 3, classic integers problem, adding and subtracting. The number one reason students struggled on the quiz is because they couldn't add or subtract integers correctly. So for number 3, you need to use the counters method or number line method to simplify integers. You must use one of these two methods. Don't do it mentally. Use one of these methods because so many students are still making this mistake on the quiz. For number 4, this is the error analysis problem. Answer the problem carefully by identifying the errors and revising the work. There are 2 mistakes in this problem. So describe the errors and then fix it. For number 5, did you know that there are multiple ways to solve the equation? Here's an example. So method 1 and method 2, exact same problem. Subtract 4x on both sides. Then you're left with 17 equals 3x minus 13. Then add 13 on both sides. And you get 30 equals 3x. Then divide by 3 to get x by itself. And x equals to 10. So the first step in method 1 was subtracting 4x. For method 2, they use a different first step. They subtracted 17 instead. So subtract 17 on both sides, and you get 4x equals to 7x minus 30. Then you subtract 7x on both sides, and you get negative 3x equals negative 30. Then solve for x by dividing by negative 3 on both sides, and negative 30 divided by negative 3 equals 10. Notice how the first step for both methods are different. They have a different first step. However, they produce the same result. Wanting you guys to do practice with this is because there's more than one way of solving each problem. It still gets you to the same answer though. So the same problem, want you to do 2 different methods. Same problem, do 2 different methods. I will remind students a common thing that I saw on the quiz is that students want to do subtract 4 on both sides. That's not what you do first. Remember to always combine like terms first. So you want to do 4 and negative 23. Combine them first. Don't subtract 4 on both sides. That's it. If you have any questions, please attend office hours.